Welcome to the Advanced Isar Database tutorial. In this tutorial, we will learn everything we need to know on Isar Database from the basics to more advanced concepts. You don't need any prior knowledge of Isar Database to get started. Everything you need is right here. In this tutorial, we will build a simple expense tracker app designed to help us monitor, manage, and analyze our expenses. We will create a budget to creating expenses for different days and set them in different categories, set the different types of payment methods that exist. We'll also perform uploading of files or images and also set up our tags, and our expenses will be stored and displayed. For today's expenses will be displayed in the home screen, while all the expenses will be displayed in the third tab, where there will be an expense log screen that will allow us also to filter through all the expenses that we have. There are millions of queries that you can generate from this. So what we will be building this up with is Flutter and Dart, Isar Database itself, and also Riverpod. Riverpod, the way the project is designed, it will allow for those who are not interested in Riverpod, they can actually skip that section and still be able to implement Isar Database easily. I'll get to show you that. So if you're new here, please subscribe and let's get started. So what is Isar Database? Isar is a cross-platform NoSQL local database made for Flutter. So what does that mean? Cross-platform means that it can run across multiple platforms, in this case from Android, iOS, desktop, and web platforms. This is relative depending on the versions, but that's the intention, because there are versions, previous versions that have stopped supporting web, but they tend to bring it back up. This is possible. The concept of running across multiple platforms is possible because of Isar has two storage engines: the ultra fast Isar engine, which is the Isar core, and the SQLite engine, which is basically a wrapper around SQLite. And that's what we tend to use in creating, integrating Isar database with our mobile app. And for web, they tend to use Isar core. Isar being a NoSQL database means it stores data in other means such as JSON documents other than the tabular format in relational databases like MySQL or PostgreSQL. Isar is built in locally, meaning that the database is stored on the local platform. That is, if you're creating an Android or an iOS app, it will be stored in the mobile device or computer for desktop or web. In addition to all of that, Isar has specific features built in it. It is highly scalable, meaning it can store hundreds of thousands of records in a single database. It supports asynchronous query execution. What that means is that when a query call is executed and a future is created, right, that waits for the response from the database and returns the response when it's ready. And this avoids blocking other calls, query calls, from being made. Another thing is that Isar is open source. The original source code is freely available. It is also ACID compliant. That means ACID means atomicity, consistency, isolation, and durability. Atomicity means that it prevents updates to the database from occurring only partially. Consistency means that the database is left valid even at the point of error. Isolation means that each transaction is executed concurrently as it retains the state of the database. And durability means that the data is retained and unchanged even if the system crashes. Another important feature is full text search, which is a comprehensive search method that compares a word being searched against every word within the database. And lastly, Isar provides static typing, which is essentially checking that it's what it means is that checks are made to detect errors quickly and reduce the time spent on debugging for the developer, which is a bonus for us. So, question: so why would I need Isar database, or why would I need a local database in my mobile app? So it provides offline access. Users can access and interact with the app even without an internet connection. Next is that it provides faster access. Users can access data quickly locally compared to fetching from a remote server, which provides app responsiveness and reduces the server workload from the application. Next is that that is data persistence. Is that user preferences, for example, or settings that involve your app, they can be stored locally, offering a personalized experience even when the user does not have any internet. And another important factor is that it can cache data. Frequently accessed data can be cached locally and reduce the need to repeatedly download from the server. And lastly, will be reducing data exposure. Not all data needs to be transmitted over the network, and this can reduce the risk of data breaches. So, those are important use cases to consider and look at whether your application would actually benefit in all this. So, with that in mind, now let's create our project. So we'll start by creating a new Flutter application for our tutorial, and we'll call it expense tracker. So we'll run the command flutter create expense tracker. Let's navigate to our Flutter application. There we have it. So we'll start by pubspec.yaml. We get to see the dependencies that we'll need to be able to implement Isar database. We'll start by running flutter pub add Isar. Isar is it's the main package for Isar database that we need. So we are installing version 3.1.0. Then we'll have Isar Flutter libs. This contains the Isar core libraries for the Isar database, so they work hand in hand. Then we'll install the path provider. The path provider is the one that will help us get locations on the host platforms, mainly our mobile device or our simulator. Then we're going to install development dependencies. I will need to generate our code, that is the Isar generator and the build runner. The Isar generator is the code generator for the Isar database, and the build runner is a regular build system for that code generation. So there we have it. Isar generator is 3.1.0, equivalent to the Isar. So with that, let's proceed to the next. Start by defining and accessing our Isar database by calling widget flutter binding.ensure initialize. That means it allows us to initialize a few parameters before the run up function runs. So we'll define a variable that will get a path where we're going to store our Isar database using the get applications documents directory. Then we'll define an instance of Isar, which we'll later initialize down below. So we'll use an async await operation and call isar.open, which is the method that allows us to open an instance. And some of the arguments will be a list of schemas, which we haven't defined yet, then our directory, which will be dir.path, and then the name of our instance, which we'll name it as expense instance. So next thing is we just want to do a small check where we make sure if the list of instances are empty by running isar.instance names.is empty. That's when we open it. Otherwise, let's use the current existing instance that's already there and running. Great. So we'll get an error that at least one collection needs to be added. We haven't created any collection yet. Let's proceed to do that. So let's talk about the schema. The schema, what a schema is, it's a definition of the collections that are within your database. Collections is relative to that tables in relational databases. So we have four collections that we'll design for our project, starting with the budget. The budget collection will hold an ID. ID is a unique property that will define the uniqueness of every object that's inserted in this specific collection. Then we're also going to hold the month in type int, and it will also set it index it to be unique, so it's equivalent to having a foreign key in the regular relational databases. Then we'll have another property called year, which will also be of type int, and the last one will be amount, which will be of type double. So that means that we're going to be creating objects of different months. So if the month is November, we're going to have a budget specifically for November of this year, and then it will be holding this amount. Great. Next, we're going to have income. The income will just display a list of incomes in terms of string. It will also have a unique ID with it to be able to identify the uniqueness of every object that's inserted in the collection, and the name will just refer to a string of income sources, for example, bank account, cash, credit card, and all that. And there's a unique reason why we have this. It helps us to talk about data synchronization in a later part of the tutorial. Next, we have the larger part of the largest collection that we have, which is expense. The expense will also have an ID, and in Isar database, you can actually auto increment your ID. We'll also index the amount, which will be of type double. Then we'll have the date, which will be of type date time, and then we'll have an enum type, which means enumeration, an enumerated property that will be able to hold a few enumerated values. Then we'll have a subcategory. This subcategory is an embedded object, so we'll get to see how embedded objects look like and how they're designed, and the same for enumeration capabilities. Then we'll have receipts. Receipts will actually show us how Isar links are designed. So we're going to connect the expense collection with the receipts collection, which is the next one here, and we're going to, when you use Isar links, you're actually creating a one-to-many relationship. If you want to create a one-to-one relationship, you just use Isar link. Then we have the payment method, which will help us showcase composite indexing, where we're going to index it with the amount. And then lastly, we'll have the description, which will be of type list string, and this is where we get to see the what full text search can do. Lastly, we have the receipt collection, and the receipt collection will still have the ID, and then we'll have the name of the receipt. What receipt means in this project, it means the photos or the files that we'll be uploading. So when a user enters an expense, enters the amount, the date, the category, they can actually upload a receipt, which will be a type. We're using of type image right now, but we're going to use a file picker so that you have the option to actually decide to use other types of files, but this time we'll be uploading images. But what we're going to do in Isar database, or in this project, is that we're not uploading there's an older version of Isar database where you could actually upload the file into the Isar database, but they decided to remove that. So now the best option to do to actually handle uploading of files is actually storing the name and then uploading or storing the files somewhere in the device, and which is actually efficient because you tend to not overweigh the Isar database itself with blobs and all. So what we're going to do with the receipt, we're just going to be storing the name, which is actually the path of the file linked to this expense, and then we're going to access it in that place. So we're mainly going to use the get applications directory from the path provider to help us to actually have a place where we can upload these files. And then what we're going to be storing here is a full path to those files, so that you can actually display them in the application after creating our expense. And lastly, we'll have an expense property that will just help us understand what reverse relationships are. So it's a way of reversing a relationship. If I want to get in this case, we're getting one to many, right? So one expense is equals to a number of receipts. If I want to know this specific receipt, who does it belong to? That's what reverse relationship is. So with this property, I can be able to know which expense is related to this specific receipt. That's what backlink generally means. So with these 4 collections, this is the whole schema that we're going to design. Let's proceed to creating it. Let's create a new folder called collections. I will hold all our collections. We'll first design the budget collection in our budget.dat. We'll define a class called budget, and then we're going to annotate it with at collection, which could be capital C or small c. Let's define our first property, which will be of ID of type ID, and initialize it with isar.auto-increment. Then our next property will be month of type int and set it as late, meaning that it may not be initialized here, but it will come initialized. And then the same thing we'll do for year, which will be late int year, but the amount will be of type double, but will be nullable. Okay, and then we need to add a part file. With this is very important for the code generation process. That's where the generation of code will be set. Next, we're going to define the expense collection. So we're going to define another class called expense, and then we're going to annotate it with at collection. Let's start designing our properties, starting with ID of type ID is equals to isar.auto-increment. You can decide to define your own IDs and even set them as string. Then we're going to define another property of amount of type double and set it as late. That means it won't come nullable, it will later on be initialized. Same with date of type date, which will also be late. Now we're going to define our enum values, and we're going to call it a category enum, and our categories will consist of bills. We'll also have food, clothes, and then transport, fun, and others. There's also room to actually want to create your own categories in the app, but in this project we're just setting them up as is. Then we're going to define our category enum, which will be called category, and define at enumerated enum type dot name. Next, we're going to design an embedded object. So this is how we design an embedded object. It's just like creating a class subcategory that we define the properties for this class, which will be name, and then at the top we annotate it with at embedded. Then we pass it in as a property in our expense class. Great. So that's also allowed to be nullable. Next, we're going to add receipts, which was another important property, but I'll get to show you that when we talk about links. So we're going to add a payment method, which will be of type string. Then lastly, we're going to have another property called description, which will be of type list string. Let's add our part code, line of code, which will hold the generated code for this class. Next, collection will be receipt. So we'll define a class called receipt, proceed to annotate it with at collection, and then we're going to define our first property, which will be ID. And in this case, you can decide to generate your own IDs. Isar Database also allows string IDs. So we'll have our name of type string, and then lastly we'll have the expense property that we talked about. So let's just add a receipt of type receipt for now, but we'll end up changing it when we talk about links. So let's add our part line of code, where our code will be generated by Isar generator and build runner. Lastly, let's create our income collection. So we'll define a class called income, annotate it with at collection, and then inside here we'll simply have the usual unique property ID, and then we'll have the property called name of type string, and add our part line of code. So database indexes are pointers to specific fields or properties in the database collection or in database tables. So what they do, the main purpose is to optimize search functionality or the search performance. For example, if you have a reference book, at the back you may have an index, and it helps you find a specific information by pointing out the page where it is. So you don't have to scan a whole book. That's what database indexes do in the database. You don't have to scan through the whole database. So back to our collections, we'll start by start in our budget collection. We're going to index our property or our field month, and we're also going to set it as unique so that it has a only unique values are set there. Another thing we're going to do in the expense section, we're also going to add an index on the amount, and also we're going to add an index where else, in the date as well, so that and also when using indexed fields or properties, we get to use it to using the where clause rather than the filter. We're also going to index a payment method, but we're going to give it the composite index because you're going to index to it together with the amount. We'll get to see that in one of the filters that we're going to incorporate. We're also going to add in an index in our description field, which is very useful when performing full text search in our Isar database. And we're going to set the case sensitivity false so that it doesn't matter which setting, whether it's uppercase or starts with lowercase. In our receipt, nope, I think we are good. And also in the income collection. So basically that's it. So let's look at database relationships, which are associations between different collections within the Isar database. So the concept that is used in Isar database to create database relationships are called Isar link and Isar links, and we also have backlink. So in our expense collection, we had defined an instance of receipt collection, but now what we're going to do, we're going to define a variable called receipts of type final, and then we're going to create a relationship or association between expense and receipt using Isar links. We're using Isar links because we are allowing one expense to be able to have more than one receipt object. So in our receipt collection, what we're going to define is something called a concept called backlink in Isar database. What it does, it's now doing a reverse relationship where if you want to get which expense a specific receipt belongs to. So it's a reversal relationship, and we set the two to the receipts variable that we defined in the expense collection. Then we need to define a variable called expense and connect it with the Isar link concept without the S. That means it's only a one-to-one relationship. Great. So with Isar links, it's a one-to-many or a many-to-many relationship if you want to do that. But if without the S, which is an Isar link, it will always be a one-to-one relationship. Great. So those are the two collections where we get to interact with database relations or relationships. Now that we are done with adding the indexes, relations, and designing our collection, we just running the build runner so that it can create our code generated files thanks to the Isar generator as well, and there we have it. So now we can proceed to add our schemas in our open function that we created when defining our database. So we'll start by adding the budget schema. Next will be the expense schema. We'll have the receipt schema, and lastly will be the income schema. Great. So if we run the project, we won't get the error that we had before. Isar Database has this awesome web platform called Isar Inspector. So you can access it with the link that they provide whenever you run your application with Isar Database. So here is the platform, and this is how it looks. It's very simple and manageable. So you can set your Isar Inspector to light mode or dark mode. You'll be able to see all the collections that you have and their properties. You even get to see the instance that you have created, or instances if you have more than one. You get to execute queries in the specific collections and see the results, which is awesome. You get to even import the data and also download and even delete. And there was something about this web platform, you get to troubleshoot and play around with data that is actually in the local database. We'll get to see that. Now, with all that we have looked at, we finally get to do the fun stuff, which is the data logic, and we'll start by the data abstraction. So we're going to create an abstract class that will provide a base for our repository classes for our different collections. So we'll create a folder called repository, and inside it, we'll create a file, a file that will called adapter that will hold an abstract class. Our abstract class will be called an adapter of type T, generic type. Okay, so we need to consider a number of methods that we may need for when implementing or interacting with Isar database, starting with the create object. We'd want to create an object in a specific collection or collection of type T. Another thing would be we would want to, Isar database provides the option to create multiple objects, not just one at a go. So we'll need to pass in a list of collections of type T. And then we'll set the type for the function, for the method, as future void. Next, let's create another method that will allow us to get an object by ID. So we need to have, the method requires an argument called ID of type int, and we will return, or the function will have a type of future of generic type T. So next we're going to have get objects by ID. So if you notice with Isar database, they've really provided extensive methods for us. You can be able to create an object, but not just one object, but multiple objects in one method. You can create and get object by ID, but you can also get objects by IDs. Then we also want to get all objects in total in a specific collection. So our function will be of type list, type T. So far we have done the CRUD factor, create, read, and now let's look at U, which is update. So we'll need a method called update object, and it will pass in the variable of type T called collection. And then we'll have delete object, which will only need the collection or the type T, depending. So T refers to whatever we'll pass in. We may pass in the budget, expense, receipt, or income collection. Then we lastly have delete multiple objects. We have the option to do that in Isar database, which is cool. All we need to pass in is a list of IDs of type int. So that's how our abstract class looks, and that will be the base of the repository classes that we'll create. And in that, we'll proceed to now interact with Isar database. We'll start by creating our first repository class, which will belong to the budget collection. We'll create a class and name it budget repository. We'll proceed to extend the adapter class and pass it the generic type of budget, which is our collection. Then let's add the overrides. And there we have our skeleton. Now let's start working on our first function, which is create multiple objects. So we'll pass in an async because it will be an asynchronous operation. Await, and then we call the Isar instance that we had initialized in the main.dot. Call the write transaction method, which executes an asynchronous read and write transaction. Then inside it, that's where we go proceed to get our budget collection. And we use a put all method to create multiple objects. So our argument will hold a list of budget collections. In the create object, we'll proceed to do the same. Provide an asynchronous operation, call our write transaction method from the Isar instance, and then we're going to call our Isar again and get the collection that we want to use, which in this case throughout will be budgets. Then we call our method, which is put. The first one was put all, but this one is put, and we'll pass one budget collection, one budget object. Same thing with delete object. We pass in an async operation, call the write transaction. And in the delete object, what we do is call the isar instance dot budgets dot delete method and pass in the ID of that specific object. For delete multiple objects, we have arguments of a list of IDs. So what we'll do is we do the same, pass in the IDs in the method delete all. For get all objects, we don't need to, if you notice even in the delete, we don't need to call the write transaction method. But, and also in the get all objects, all we have to do is get the Isar collection, which is budgets, and pass in the where clause dot find all. So it will return all the objects in the budget collection. For get object by ID, we pass in a sync operation, and then we just proceed to call the Isar instance and the Isar collection, which is budgets, and use the method get to and pass in the ID of that object. It will return a budget object. For get objects by ID, it's the same thing, but now we're going to be passing a list of IDs. Instead of get, it will be get all. So you can see how Isar has really abstracted and created so many methods that are useful to interact with inside it. So the next one will be update object, and whenever you're creating or updating, manipulating the Isar database, you need to call the write transaction method because it's the one that executes a read and write operation. And then what we're going to do in the update, we're going to first get whatever has been passed in our argument. We get the ID. We get the object based on the ID that has been passed in the argument. And if it actually exists, because we don't want to update an object that does not exist. And if it exists, that's when we put in whatever has been passed, which must be the updated. So you'll find for create and update, they use the same method, put. Next, let's create another repository for expense. We now know the drill. We just create a class called expense repository. Then we proceed to extend the adapter class and pass it the generic type of expense. Then we add the overrides, and now we have our skeleton, and the logic will be equivalent to what's in the budget repository class. So let's just add all that. And then we'll just change the Isar collection from budgets to expenses. Now we are done with that. Let's proceed to create a repository class for the receipt collection. So we'll define it as the class name will be receipt repository. We'll extend the adapter class and pass it the generic type of receipt. Then get the overrides and proceed to work on our skeleton. Now instead of budgets, we're going to use the Isar collection receipts. Great. Now let's work on the last repository class, which is income repository.dat. And our class will be called income repository. We'll extend our adapter class, pass it the generic type of income, then proceed to add the overrides, and now work on our skeleton as well. So instead of the Isar collection budgets, we'll have incomes. Great, we are done with that. Now let's focus on queries. Querying is how you find records that match a certain condition in the database, in our case, the Isar database. So in our budget repository class, other than the overridden methods, we're going to create individual functions for this specific repository, and we'll call it get object by date. We want to get a specific budget for a specific month and year. So it will return for us a type of budget object. So inside our function, we're going to return by calling the Isar instance dot the Isar collection budgets and use the filter clause. Then we're going to be provided with options. So we'll use dot month equal to the argument passed, the dot year equal to the year that has been passed in the arguments, and calling dot find first. So that will return for us only one object of those specific conditions that we have provided. Great. Now that we'll proceed to the expense repository class. Other than the overridden methods, we also have specific functions that are specific for this Isar collection, which is expense. So one of the functionalities that we need is to get the list of expenses for the current time or today. So we're going to call our function get objects by today, and it's going to return a list of type expense. So to get our output, we'll need to call the Isar instance and then dot the Isar collection expenses, and then we're going to use the where clause. because whatever we need already has been indexed, which is date. So we have the option to use the where clause, and the beauty of that is that it will optimize the search performance. So we're just going to say dot date equal to the date time dot now, and then we're going to set all the times, the hours, the minutes, the seconds, the microseconds to 0, so that you can get all the list for the current day, whether or not it was 2 hours later or a few seconds later. So the beauty of where clause is that you get to use your indexed properties, and indexing, as we said, it helps with optimizing the search performance other than the filter clause. Next, we need the function that gets the sum for category. So it returns for us a type of double, and we'll be passing an argument of type category in num, which we had specified in our expense collection. So we're going to call the instance isar.expenses.filter category equal to whatever we've passed in the argument. And then we want to handle with the amount property, you see. So the amount property is the one that will be executed, will have the execution of dot sum. We're going to get the sum of the amounts of that specific category. So you need to specify that. Next, we have a function called get objects by category. And what this will return will be a list of expenses, because now we're going to get the objects in the expense collection that have a category in num or that has been provided in the argument, which is value. So we call the Isar instance.expenses.filter category equals to the value that has been passed in the argument dot find all. So it will return all the lists of objects that have that category. Next, we'll have another function called get objects by amount range, and a range involves one value to another value. So we'll have a low amount to a high amount, and it's going to return a list of type expense. So we call our instance isar.expenses.filter amount between. This is all provided by Isar. You don't have to create it, so it already provides those methods for us, which is awesome. Then you specify the low and the high, and you can specify either you want to include the lower or not. Then you pass in dot find all. The next function we're going to create is get objects with amount greater than, and we're also going to return a list of type expense. We're going to see how all this will be implemented in the app. We'll have very many filter options, so we'll get to see that. So what we need as an argument is an amount value of type double. And with that value, we're going to go to our expense Isar collection and filter out by setting the amount greater than amount value dot find all. So it will provide us all the list of objects that have amounts that are greater than the value that has been provided. Please note that all these methods come with Isar. We didn't create amount greater than or amount less than anywhere, which we have done now in this next function. We've just used the same logic, but now getting amount less than. Now we have another function for get objects by options, and it's also going to return a list of type expense. So options means we want to give the user we want to be able to provide a list of objects with the option of whether they have a category is equals to whatever has been provided in the argument, or the amount high value is whatever has been provided in the argument. So we run isar.expenses.filter.category equal to the value that has been provided in the argument, or amount greater than the amount that has been provided in the arguments, and passing find all. So that's how we use the or method. Next, we're going to create another function that gets objects not others category, meaning list of expenses that are in all the categories other than others. So how do we do that? First, we make sure that we're returning a list of type expense. Then we're going to call Isar dot expenses dot filter, and then we're going to say dot not and specify where the category is equal to others. So it will provide for us all list of expenses that are not in the category of others. Dot not. Great. Now we want another function that gets objects by group filter. So we'll need an argument that has a search text or what a user will enter for searching, and also the date time. So we will also return a type of list of type expense. Then we head over to call our Isar instance.expenses.filter. And then we're going to get where category equals to category and num.others. So in this case, we're just focusing on where the categories is others. And then we're doing a group where the queue, the payment method, contains the search text that has been provided or the date time that has been provided. So that's how you group or do group filtering. So if you have, for example, an embedded object, that's almost equivalent like to joining when it comes to regular relational databases. Maybe so. But that's how you perform group filters. Next, you're going to have get objects by search text, which is simply the user passes in the search text in type string, and we call our Isar instance.expenses.filter and check where payment method starts with search text. So in this scenario, I'm just trying to show you the options that we have in terms of filtering. So you can either say starts with search text or ends with search text, and there's also contains with, so there's room for that as well. So next we're going to create a function that handles the concept of any. You want a list of expenses that have any of the filters. So we'll say isar.expenses.filter any of categories and then of type category and num. And then we're going to say where q.category equals to a list of categories that will pass in our argument. So the user might select a few categories, and then we'll head over to what the filter will do. We'll head over to the expense collection and check through expenses that either have the list of the categories that we have given, either others, bills, and all, and returns them. So that's what it does. So the same thing with get object using all of. All of means that these specific expenses should have all these categories. This won't be equivalent in our case because every expense is given one specific category. But in the case where we're creating an expense and it can be in more than two categories, it has to check these expenses must be within the list of categories that have been provided by the user, selected by the user. So that's why you use all of, and that's in Isar Database. Another function will be get objects without payment method. So we'll return the list of type expenses, call Isar instance.expenses, and do a filter where we check payment method is empty, find all. That's how you do it. Then another function will be get objects with tags. The tags we refer to the description property that we have. It holds a list of strings. So what we want to do in this case, we want to check where the expenses have more than a specific number of tags that the user may have selected. If the user passes that I want list of expenses where the description length is 2 or 1 or 3, that's how to do it. So we say description length equal to, because it already identifies the description property as a list. The next function will be get objects with tag name. So we are going to return a list of type expenses, call our instance and our Isar collection, calling the dot filter, and then we're going to go and say description element equal to whatever the user has passed, which is tag word And you can also specify the case sensitivity. In our case, it's false. So it's going to check through all the description, the strings in the list, and be able to get if it is any that has the element that you need. In our get objects by subcategory, we're just going, what we do, this is how to actually filter in an embedded object. So what you do, you just call the subcategory, and then you create like a group where you just call it and now specify the attribute of that embedded object, which is only name, and then dot name equal to whatever the user has passed. Get objects by receipts, we pass in the string receipt name. This is, remember, the receipt refers to the photos, so we're searching it using the photo name. So we'll just go and say isar.expenses.filter.receipts, and then we'll proceed to check where q.name equals to whatever the user has passed, or q.name contains whatever the user has passed. So those are a few options that we have, and then we find all. So in this case, I have added a concept or a logic on receipt, but it's still fine. Next function that we can create is get objects and paginate. So pagination is one of the a very important factor either in web and also in mobile app, where you decide a list of items that will be displayed in one page, in the second page, and all that. So we can use isar.where, and we can specify the offset and the limit and get all our expenses. So all our expenses will be controlled by the offset, which will be passed. So get objects with distinct values. This is why you want only unique values to be passed in. So all we have to do is use the where clause. So as you can see, what happens when you're using the where clause, high probability the properties are indexed, unlike filter. So if you decide to use filter and you want an indexed property, you may not find it in the drop down or in the list of methods that have been provided. Let's create another functionality, which will be get only fast object. So we just want to get the first one. Then we're going to specify a variable called query selected. Then we call our Isar instance, passing our Isar collection expenses dot where find fast, and then we check if the value is not equal to null, query selected dot add the value, and we return our query selected. So we're only getting the first object. Delete only first object. We're going to do the same. So the question will be, if I'm getting only first object, why do I need a list? It's in the way we have designed to the on the side of Riverpod. So if you're not going to use Riverpod in these two functions, you can just return the expense object alone. I'll get to show you that. So for delete first, we just call in the delete first method from our where clause, and we get all our expenses. We return all our expenses after deleting the first, so that you can see what if the first object was deleted. Then there's the get total objects, where we get the total count of all the list of expenses that we have. So it will return a type of int. Another function that we'll create is clear data, and we're going to give it a type of void. So we'll just proceed to call our write transaction method, and just pass in the logic of isar.clear, which will just clear all the data in the Isar database. We'll get to see that there's a button that does that. Then we have another function, get payment property. You may want to actually get information of a specific property in a collection and not just the whole information. So this is the function for that, and we're going to use the where clause dot payment method property dot find all. But yep, done. So it will return that when you specify the property, it will provide the list of payment methods only. Next, another functionality will be total expenses that we'll need, and we're going to pass in the future of type double. So this is going to get the sum of all the expenses that we have, and that's what we are going to see displayed in our home screen. So you just said you have to specify the amount property when you're using aggregation functions like dot sum. So we are summing up which property, that's what it means. So we are summing up the amount property. Then for the total expenses by category, we're getting the sum for each category distinctively. So we're distincting by category and using the amount property to get the sum. That's what we have done with that function. So it will return for us a list of the sums for the categories. Then we have the important functionality for full text search, where the user passes a search text, and what we do, we call the Isar instance dot expenses dot filter dot description element equal to the search text. So we're going to use the list string to do our search, equals to the search text, or the element we are focusing on, the element starts with the search text or ends with the search text. So there's the options are so many, so you can be able to check on that. So we'll be checking if it's equal to, if it starts with, or if it ends with. But there's also the option of using another method which is the contains. So you can also say description element contains. It all depends on the type of output you really need. So with that, we are done with the functionalities in the expense repository. For the receipt, we just had one that we actually added in the expense repository, but we have like 3 more. For there is a functionality of uploading receipts. So we want to upload the receipts, and the argument will be a list of type receipt. So we just call our Isar instance and call our Isar collection receipts, but because we are manipulating or modifying the database, we need to put it inside the right transaction. So what we're going to do is we're going to loop through the list that we have received in terms of argument, and in each we're going to call isar.receipts.put, and then we pass in the receipt. So another way to do this is just, instead of doing a for loop, you just call put all. So those are 2 options that you can use. Another functionality that we can create is download receipts. So downloading is like we are reading from the database, right? So what we are going to do is get the total receipt. So I'm showing you other options other than put all and get all. So the first one was, I was showing you how to use the loop. But another way to do it is just using the method put all. For this second one is we're going to get the count of receipts, and then we do a for loop inside the right transaction. Another way to do this will be just to get all, use the method get all on the Isar collection receipts. So we're getting it using the id.findFirst, and then we're adding it in our list of type receipt, and that's the one we're going to return in this function. Great. So another option to do this is by just calling the get all method. So there's so many options, guys. Another functionality that we can add is clear gallery. We're going to have a gallery in the app, and we may want to actually clear it. So since it's a modification of the database, we're going to use a write transaction method, and then we're going to do another for loop inside it. So as you can see, I'm showing you other ways of doing other than calling the methods. You may need to actually use some different logic. So this is one of the ways. but either way, the methods of Isar are still good. So we're doing a for loop, and then we through the receipts or the list that we have been provided in the arguments of the function, we are deleting each and every one. But you remember we have delete all in Isar. So this is just a way of playing around and seeing other ways that we can do it. So we have put all, delete all, and get all. So you can use those instead of doing a for loop inside the right transaction. But this process teaches you on how transactions work as well. So let's work on our mixing class. Our mixing class is the one that's going to be the intermediary between our app UI and the that logic that we have been working on. So I decided to separate the two. So we're going to now start interacting or creating the logic based on what we will need on the app level in terms of buttons, in terms of on change, any action listener that we have. So we're calling our mixing class func, and the first function that we're going to create is create budget, which is found in our home screen, and all we need to pass is the amount. So we're expecting to receive the budget object. So all we do is define a variable called budget and design our budget object here. So we're just saying budget dot setting the month to date time dot now dot month, which returns an int, and dot year returns the actual year in number. Then we set our amount. So our object is ready. Now we just head over and call the budget repository class and call the function create object and push or add in the object that we have created. As simple as that. So this create budget is what we're going to play around with on the app UI. If you're not using Riverpod, if you're going to proceed with the Riverpod section, I'll show you what we're going to do. In this next function, we have get budget. So we want to get a budget for a specific month and year so that we can display. So what we're going to do is just call the budget repository class and call the get object by date and pass in the month and the year. We're going to call the promise that will return for us a budget, a result of type budget. Our next function will be update budget. We're going to have the option to update a specific budget, and we'll just call the budget repository class dot update object, and then we pass in the specific budget that has been passed on as an argument in the from the app level. Another functionality will be create expense. We'll be creating the expense in the second tab. So there's a number of arguments that we'll need to pass in. Let's just put it in the right place. Yes. So we'll have the amount. The user will enter the amount. The user will specify or choose a date. They'll also choose the category. They'll also add in a subcategory in type string, and then they'll also like upload receipts and specify some tags which will represent description, and also select a payment method which will be of type string. So with that set, we'll need to create an expense object. So let's add all this depending on the property. So for property amount, we'll pass in the amount. For property date, we want to format it so that we don't have to, we just pass in the date without having a specific hour, minute, or second. So let's just have all of it 0. Then we'll just pass that formatted date over here. Another thing will be subcategory or category. So the category the user will select. Another thing will be subcategory. Remember, subcategory is an embedded object. So we need to design it. So it will just call the subcategory class and set the property of name to whatever the user will add as subcat, which will be of type string. Then we pick our subcategory and add it in our property. Then for the description will be whatever the user will pass as description, and the payment method will be the same. Now for the receipts, remember receipts is a class, is a collection, sorry. So we need to design it. The user returns in the arguments we are passing in a set. of receipt. Set is also equivalent to list but with unique values. So we're just going to do a loop and create these receipts first before we add them in the receipts property in our object. And then all we have to do is pass in dot add all and passing the receipts after creating them individually in the receipts collection. After that, now the object is done. We just called the expense repository class and called the create object and passed in our object. So that's how you add another receipt collection into the expense. Remember, they were connected through Isar links. The next functionality, get today's expenses. We are going to just call the expense repository class and dot get objects by today. And that's all we have to do. Then we're going to just call in the promise that will return for us a type of list of type expense. Another functionality will be get all expenses. So we want to get a list of all the expenses. So it will return for us a list of type expenses. We call the expense repository and call get all objects and just call in the promise that will return for us our result. For get path, we need to get the path that we're going to be uploading this images or receipts per se. So all we're going to do, we're going to call the directory which is in the path provider package and get application documents directory. This is the same place where we are storing our Isar DB, and just return our path which we're going to use in the code. We have another function called get all receipts. So this will return for us all the receipts, and we're going to use a receipt repository class to get all objects. Another functionality will be clear data, and this will involve the expense repository. We added that functionality there and just called the clear data method. Another functionality will be get total expenses. So we're getting the sum of the list of expenses. So we proceed to call the expense repository class dot total expenses, and it will return a double. So another functionality that we'll need in our app UI will be getting the sum by category, and we already set that in our expense repository. So what the result that will come in will provide all the sums of all the categories. So there's a way we want to manipulate what we'll receive. So if we call expense repository dot get sum for category value, this total dot it's going to be getting we're going to be passing in the specific category, and then it will once we get the sum, we're adding it in a variable called total so that we can get all of them inside a list, and then we'll know how to display them in our app. The functionality expenses by category, we need to pass in a specific category so to get the list of expenses of a specific category, whether it's bills, foods, others, and all. So to do that, we're just defining a variable called expenses, and then we're just calling the expense repository and get objects by category. It's expecting us to pass in a category type, and then we just define our expense with whatever value that is returned. Expenses. Okay. Then we have expenses by amount range. Now these are the filters that we already designed in the response repository classes. So we'll start by designing them on how we're going to, now we're just manipulating how we're going to get them. We are going to add them in a variable called expenses, that is list of type expense. So we're giving it a range of low and high of type double, and we're passing it in the method for expense repository class, and we'll return it and initialize it to the expenses variable and return it. Okay, so we're just going to duplicate the function so that you can create for greater than, and all we need is the amount, one variable, and we'll call the get objects with amount greater than from the expense repository class, just duplicating again and now passing in get objects with amount less than. We'll get to see these filters when we design the UI. And yeah, next will be expenses by category and amount. This one explains the concept of group of options, where you have the option to select this or that. Great. Next, we'll have a function that gets list of expenses that are not of category of type others. So the idea is, instead of calling the math function straight from the repository classes, this mixin class is allowing us to play around to do any manipulations that we may need. That's why we have it. Another option will be to call from the repository class itself, but ideally I wouldn't advise, because we're really trying to create a form of separation of concerns here. And then we just want the mixing class to be a place where we can play around with manipulating any input that the user inserts, but everything else stays constant. So as we proceed to call all the functions that we need from the repository classes, the option where we get to play around with it is in the mixin class, or play around with the input or the output that we get from Isar. So that's the function that the mixin class has. So we're now at creating the function for expenses by using any. So we'll get a list of expenses that have specific categories, any of them. So that's what Isar will do. So let's just add in the type. Let's add the logic for using all. Expenses by tag, so we'll pass in int tags, so the number of tags the user wants, the list of expenses that have a specific number of tags depending on what the user passes. And then this one is tag name string, passing in the subcategory name. So we'll call the function or the method get objects by subcategory. And you'll find that the functions are quite equivalent, because the main logic is in the repository classes rather than in the mixin class. The mixin class is more of like an intermediary between the app UI and that logic that we have created based on Isar Database. So just adding all of them and connecting them to the respective functions in the repository classes. That will return for us the list of total objects, list of total expenses, the total number of expenses, sorry. So for the full text search, we'll need the user to pass in a search text, or search text means whatever the user decides to insert to search. object. Then we pass in our object, which is called collection. So let's just manipulate the delete object. We don't want it to pass void, we want it to pass the list of expenses that are currently there. Mm, For clear gallery, we'll get it in the receipt repository class. Pass in the receipts. And we are done with all the functions in the mixin class. Now let's have a look at Riverpod, which is a state management tool or framework that has been requested actually over here a lot. In our previous tutorial, we didn't use any state management, but this time we're going to use one. So we'll need to install some dependencies for us to use the state management platform. So we'll install Flutter, Riverpod annotation, Riverpod generator, the build runner, we already have it, the custom linked, and the Riverpod linked. So we have 2.4.7 for Flutter Riverpod, Riverpod annotation 2.3.1, Riverpod generator 2.3.7, and custom linked 0.5.7. So we are having issues with collision in dependencies. Let me try and backtrack the versions by one and see. Yep, I think we're okay with those versions. Now let's work on our state management phase. Create a folder called providers, and that's where we're going to also subdivide our separation of concerns, separate our logic, have one that focuses mainly on the budget collection. So we're creating a Riverpod class, which is also called a notifier, and then it comes with an overridden method called build. That's the one that it returns a specific type. But before that, let's just import the Flutter the Riverpod annotation so that we avoid the errors, and then the rest will disappear once we generate or run the build runner for the code to be generated. So in our expense budget, what would we like to manage in terms of state? We would like to always manage the value of the budget for that specific month and year, right? So that it's always displayed correctly, whether you update it or delete it. So we're going to call the get budget function in the mixin class, pass in the required arguments. Yeah, and then just return it, and we're going to return a type of future budget. It return a budget object, and inside there, that's why we're going to get the amount value. Okay, so now let's just run the build runner that the code generation phase is implemented. As you can see, Riverpod generator and build runner, they have generated dynamic code for us, and we have no errors. So our build method will always return type budget, or let me say this state will return type budget. So we're adding more methods, and whenever we call the method, like for example create, where we're passing the amount, we go and call the create budget from the mixin class and pass in the amount. But what we did in the create budget, we're not returning anything. So it's future void. So let's backtrack to the budget repository and make sure that we're returning a budget object. So all we have to do is just call the get objects by id collection.id, and now that we have the option to get a budget object, we can proceed. So we have a variable called x that returns whatever is returned by the create budget, and then we define our state. Our state will hold a sync value dot data and whatever is returned by the create budget. Okay, so that's how we're going to be handling state. So when we create a new budget, automatically the state will be updated, because in the create we are handling that. For the edit budget, we're also going to do the same thing. So we have a budget await, and we're calling the update budget, and this is already passed to, we pass it when we're calling the method. So we also want to update the type for this. So we return the object by id once it's updated. Currently it was returning void. We set that, and then now we can use it. So once we get the budget after it has been updated, we update the state with whatever is returned by the update budget. I hope it makes sense. So that's all we need in terms of handling state for whatever values are returned in the budget collection. Now let's handle the expense collection, or the logic revolving around the expense. So we're creating a Riverpod class, which is also called a notifier. Let's just import the respective package, which is Riverpod annotation. Then we'll do the same thing. So in this specific class, or notifier, what we want our state to hold is, we're going to be calling, initially it's going to call the get total expenses. So what it's going to return is a double. So our state will always have a type of double. So let's just run the build runner for a minute. So whenever we call this specific provider, it's going to be returning to us a value of type double. And by default, our build method will be calling the get total expenses function in the mixin class. Okay, so we're good. Because we need to handle a few other types of data based on the expense collection, we're creating another Riverpod class, or another notifier called expense count. It will have a different data type. We're going to go and call the function first. Let's add the mixing class, implement it, add it, and then we call the expense by count. If you remember, the count has data type of int, so we need to, that will be specific. And for Riverpod, you can either decide to create notifier classes or just use the function concept, whichever that works for you. Let's create another one, another notifier class, and this one focuses on a different type of data type. That's why they're not all together, because the build will always hold one data type. So we're going to call the sum by category. So whenever we call this provider or listen to this provider or want to read it, or watching, the build will always return of type list double, specifically the expense category provider. So we're just doing a quick build runner execution. And then we are going to create another notifier class. As you can see, all these classes have different data types. That's why we're doing so. So for the expense filter, initially we want to set the build to return an empty list. Okay. So let's just run the build runner for a minute so that we can proceed. So you'll find the reason why we're doing this, all the filters that we have performed, all the functions that revolve around filtering, if you recall, they're all returning list of type expense, every result. So that's why we're doing that. So we started with the reset result where we want to always clear the state first. But now let's proceed now to define methods that relate to the functions that are in the mixing class. That's all we're doing here, but not all of them, only the ones that we need to handle the state for. So you'll find that whatever is returned from these functions in the mixing class, they are equated or initialized to the state, the built-in state. And with all these methods being created, if in this tutorial you have no interest in Riverpod, you'll find that you can skip this part. And whenever we are calling a specific method in a notifier class, what you'll be calling is now the actual function in the mixing class, because now you won't have this section of the Riverpod. For example, we have the method filter by not others. So the state will be updated with a function that comes from expenses by not others, right? So for us who are proceeding with you implementing Riverpod, we'll be interacting mainly with the filter by not others category. But for those who are not don't won't implement Riverpod, you just call expenses by not others category from the mixing class straight away. And then use the inbuilt state management, which is set state. So let's proceed to add them. In the user interface, you'll get to see all these filter options and see the type of results that they provide. And how the state is actually handled and updated, and how the UI interacts with the Riverpod as well. Mm, seem not to have that function. Let's see. So we have expenses by tag name. Mhm. So this one should be specifically for tag name, and it should be calling the get objects with tag name. And then now we should have the one for subcategory, because the function for get objects with subcategory, what it does is it shows us how to filter an embedded object. It's not equivalent as filtering a property that's just a variable or sort. Okay, so we're back. Expenses by subcategory. Wait. Um, let's add one more. Filter by full text search. And now that we have all our logic on Riverpod set on our notifier classes, now all that we have to do is in our UI, we'll be watching and listening, interacting with the read and watch methods that are in Riverpod. Great.